Good afternoon and welcome to today's Adweek webinar, where we'll be looking at how direct-to-consumer and challenger brands are driving customer acquisition. And it's really about finding ways to win with in acquisition using deep learning instead of maybe some of those old trusted social and search options that so many direct consumer brands have used. And our webinar today is being sponsored by Cognitive. I'm Stuart File, Vice President of Branded Content at Adweek, and I'm going to be your host for today's webinar. Before we begin, I just want to take a few moments here and make sure everyone knows the features of our webinar platform and knows what to expect from our presentation today. Our presentation should be primarily slide-driven, although we will have some conversation afterwards. And as you can see, of course, everything today is on video. That presentation should go somewhere in the 30-minute range. Afterwards, we're going to have plenty of time for audience questions. So if at any point during our presentation, if you have a question for our speaker, just simply use the question tool that you should see there underneath the video window on your screen to submit your questions. And we're going to get to as many as we can, again, following our slide presentation. It's not too late to invite your colleagues to come and join us today, and we'd love it if they would. About 15 minutes ago, we sent everyone a final reminder email. In there, you're going to find a link over to the registration page. So grab that link, send it off to your colleagues. There's still plenty of time for them to register. Come on in and join us live. If they can't make it live, today's webinar is being recorded and will be available on demand. We're going to send you a link to that on-demand version about 3:30 or so Eastern time today. If you are interested in getting a copy of today's slide deck, we always like to make that available, and you'll find that in the Event Resources tab. You should also see that down by where the question tool is. So once you see that tab, you can go on in there at any point and download a PDF of our presentation today. We know a lot of people love to use that as a takeaway from the event. Lastly, I just want to remind everyone to please check out the Adweek webinar calendar, www.adweek.com/webinars with an S. We've got a whole bunch of webinars coming up through the end of June. We've got everything up there on our calendar. I think there are about a dozen or so going on there. So as you can tell, we're doing 3, 4, 5 webinars in a week. So see what's coming up, sign up for an upcoming webinar. We're updating it pretty regularly, so pretty much 2 or 3 times a week that calendar changes. You'll also get full access to our entire archive of on-demand webinars there. That's every webinar that we've done over the past year. You can check out those recordings as well, and that includes several from our sponsors today at Cognitive. All right, let me move on over here and just take a second and introduce our speaker. We're very happy again to be joined by Jeremy Fain. Jeremy is the co-founder and CEO of Cognitive. Again, he's one of the founders of the company. And if you don't know Cognitive offers self-learning, fully automated neural network technology for marketers. Jeremy has plenty of experience in the ad tech world. He had previously led North American accounts over at the Rubicon project. So without further ado, and because this always takes a second on video, let me bring Jeremy up here to begin our webinar today. Welcome, Jeremy.
Thanks, Stuart. Welcome, everybody. Glad you can make it today. Hello from my guest room / office. I hope everybody is doing well wherever they may be logging in from. Maybe people are starting to trickle back into the offices. I hope today is an entertaining interlude when we're going to really talk about the obvious. Adding and retaining new customers is the lifeblood of any business. And that is, a bit obvious, I know, but I think that we're all having some of the same challenges. A lot of our D2C and challenger brand clients have come to us with the same questions and the same problems, and we've been able to help them. So we're thinking that we should bring a little bit of our thoughts to you guys and and pass on some of that learning that we've gotten. Right now, almost everybody, but especially D2C and challenger brands that are relying heavily on social and search, are facing some of the same problems right now. Customer acquisition costs have continuously gone up in a lot of ways. A lot of that we're seeing is because of the large amounts of funding that great brands are getting from VCs and other groups to drive growth. And as we all know, growth is the king. Top line is the king of it all. But at a certain point, CAC can get to greater than the revenue that you're going to get from new customers. That is not a sustainable business model. And I think we're seeing over the last 12 to 18 months, because of COVID, that strategy is no longer as acceptable as it used to be. So we're really seeing a lot of questions about how can you help us drop customer acquisition costs for us, and can you do it at scale? Because when you get to a certain point with search and Facebook and other social, that it just no longer, the return on ad spend is just not where it needs to be. If you've experimented with anything such as lookalikes on Facebook, or if you're on other DSPs and you have an auto optimization option that you've clicked, I think most people have also found that doesn't scale, and sometimes it doesn't work at all. Most of the time that's because those algorithms are not custom built for your brand and the types of people who are have affinity for your brand. And that's become, sort of a bigger issue when you don't have an army of optimization traders, media traders, or data scientists to help you. You're finding that things are stagnating along with the optimization capabilities that you have. Trying different audiences is time consuming, setting up the experiments to figure out which ones work, which ones don't. Those audiences aren't scaling. Those audiences are not custom built for you. All of those problems are leading to an inefficiency in the customer acquisition costs. All of this always gets to a point where there's a law of diminishing returns. There's always going to be that with any channel that you work with. The law of diminishing returns will always be there. And there's a reason why we brought cognitive into being, because of this idea of deep learning. We'll get into that in a second, but deep learning is able to overcome a lot of the scale issues that other types of advertising, whether that's social, search, or other types of display and other solutions have come up with. And then finally, again, you have manual optimization most of the time. You have folks either at your agency or inside your company trying to figure out why it worked today and why it doesn't work tomorrow. And those things, the feedback loop on those things is a little bit too much of a guess, not enough of a science. So cognitive came along and tried to solve all of these problems about 6 years ago, and we've been working to solve all of them for the last 6 years. We think we've done a great job. And what we've been able to show, especially our D2C and challenger brands, is that our deep learning capabilities and the idea of deep learning in general can help you as a brand drop your customer acquisition costs to where they need to be, and you can do it at scale. We'll have some nice case studies on that. Deep learning also enables you to have a fully customized algorithm. And if you're not using a deep learning algorithm to buy, lookalike audiences that use deep learning scale much better and are much more efficient than any other kind of lookalike prospecting capability that you can get. Deep learning also, as we'll go into some detail, allows you to scale because of what we call infinite performance clusters. We'll go through that in a second. That's a really interesting advantage that only deep learning gives you. And then finally, it enables this idea of adaptive algorithmic advertising. So the fully customized algorithm, yes, it's just for you, but the beauty of deep learning is that it is always learning along the way, just like our own brains. And so we get to this new idea of advertising where we have a fully automated algorithm that is learning and adapting throughout your campaigns, different campaigns, throughout things like COVID that changed the way consumer patterns and consumer behavior for consumption works. And that's the beauty of deep learning. That's why we started Cognitive, because we want to take advantage of all these advantages, and we saw the opportunity to solve all of the challenges that people are facing together today. All right, so we'll go into a little bit of a deep learning interlude after a few slides, but I wanted to reiterate that we're hearing a lot from our customers and new customers coming in that social and search have capped out. Especially social. Now, even more recently, just a month ago, when Apple had the iOS update where tracking started to become optional and mostly vast majority disabled, we've heard this even more from an urgency perspective that customer acquisition costs on Facebook, Instagram have gone way up. And even before that transition happened, we had heard that at a certain point, especially at Facebook, the return on ad spend stopped becoming more and more positive, and sort of there was a peak at a certain point. That scale. Now, I'm not saying that there's a true lack of scale. You can get a lot of scale from social, but at a certain point it peaks and it peaks out. And that's generally speaking, not where you need it to stop peaking. And so we've heard that also, not just because of the iOS update, just because every channel you use eventually will scale out. That law of diminishing returns again. All of this is added to the skyrocketing costs that we've heard of. Walled gardens also don't allow you to get as much information and insight and analysis out of your results. So it's hard for you to figure out how to apply any of the learnings you might have from these walled gardens outside of those as you go to things like outdoor display, regular mobile, etc. Okay, so what we've been talking about mostly with our D2C and Challenger brands is this issue of social stopping to be as effective as it needs to be, especially as spend keeps growing. All right. So deep learning, I'm here to tell you that there's a solution, of course. And deep learning is that solution in many ways. Now, the reality is Facebook, Amazon, Google, they are using deep learning in their tool sets. They're not necessarily using deep learning for your benefit. They're a lot of the time using deep learning for their benefit from a pricing perspective, from an inventory management perspective, and definitely they are using a lot of that for their lookalike modeling. But as the data that they're allowed to use shrinks because of the iOS update, the less effective those algorithms are for you, the rising costs of customer acquisition. Now, deep learning we've found, especially on the open web, where you've got display, video, even CTV, mobile app, mobile display, all those things, has actually enabled a lot of D2C brands to repurpose their budgets from Facebook and Google that, past that peak. They take a look at where the peak spending and the peak ROAS is. They take the rest of those budgets, they move them onto the open web, and they've been able to, once again, lower their customer acquisition costs, be profitable in those ways, grow profitably and efficiently, while delivering new customers at a new level of scale, and in other ways actually use it for retention and retargeting, which really improves customer lifetime value. All right, so let's go quickly into why deep learning is so important, why we're talking about deep learning so much in this. If you've never heard of deep learning, that's fine, but you use deep learning actually every day. Deep learning has changed your life more than basically any technology has in the last 50 years, maybe. Maybe I overspeak because computers and all of that have come about, but let's say in the last 30 years, even as computers were getting more and more powerful, deep learning has changed our lives even more. Deep learning allows us to speak to our phones. Siri and Alexa are driven by deep learning. Self-driving cars, while not exactly ready for prime time, I think we all have had, if you've gotten a new car in the last few years, there are plenty of self-driving features built in to those cars that are helping us on adaptive cruise control and all those types of things. And then I think we're all pretty confident that self-driving cars are definitely coming soon. And that's all deep learning. That's all computer vision deep learning. Facial recognition is another way of seeing those things. If anyone travels and goes to a clear line and gets their eyes or fingers printed, that's all deep learning facial recognition. The fact that it works almost every single time is enabled by deep learning. Now, what is deep learning? Deep learning is a new way of helping computers have human intuition. Now, what does that have to do with virtual voice assistants and self-driving? The reality is, before deep learning, computers were not good at seeing, at hearing and understanding language, reading and understanding language, all of those things. What they were really good at is being told a fact, like 2 + 2 is 4, or this word is the, but not what the means, and being able to operate on those truths over and over and over again. Great. Computers could do math much faster than we could. They could create programs for us like PDFs and all those things. Great. But that's actually not what humans are really good at. Humans, in fact, are not good at memorization. How long does it take us to learn math? How long does it take us to learn English or the language that you grew up in? It takes us a long time. And while we're doing that and memorizing things, a computer can do that in an instant once it's told. Well, what it couldn't do, though, is it couldn't do the things that we do end up being really good at, which is vision generalization, language generalization, hearing and reading generalization. What does that mean? Well, if you may not ever have realized this, but when somebody new comes and speaks to you, whether they have an accent or their voice is low or high, and they're speaking hopefully the language that you understand, let's say English in this case, you generally can understand what they say. That doesn't seem very special, but a computer actually had a really, really hard time with that before deep learning was created. There was no Siri, there was no Alexa. If any of you are old enough, you remember there was one dictation software called Dragon Naturally Speaking, and it was terrible and it didn't work very well at all. And that was around for decades before all of a sudden we could speak to our phones, we could speak to our computers. Everything was pretty easily understood with very low errors. Same thing with vision. Computers could not generalize two images, meaning I could show a computer a red apple image and a green apple image and tell the computer that the red apple image was an apple, and it would not be able to, with any kind of accuracy, say that the green apple was an apple. But now that's not a problem at all for computers. And for humans, that's rote. You know, that's something that we're not even taught how to do as we grow up. Not only can you show a young child an apple, tell them it's an apple, you can then draw an abstract representation of an apple just by shape. And the child generally can automatically say that that's an apple. That's a human superpower, that idea of generalization, generalizing. All right, well, why does this apply to marketing? You know, speaking to your phone and self-driving calls, cars, and all those things. Well, what they're doing is they're generalizing voices. They're generalizing a stop sign that's at a different angle or slightly different color. They're generalizing a car shape in front of the car. They're generalizing all of these things. And marketing is basically the science of generalization, right? We're trying to find more people that are going to buy our product. How do we try to do that? We try to generalize the characteristics of the people that are buying our product now and find those people, find more of those people. But we've been doing it in a very inefficient way that's worked okay. But as all of you here are probably seeing, that only gets you to a certain point. We need more scale, and we need to do it smarter than males 18 to 49, make $50,000 a year, and live in a city. Okay, we can do better than that now because deep learning allows us to. All right, so how does deep learning work? Deep learning takes a lot of data, so a lot of voices, a lot of video or pictures, and you tell the computer what those pictures, what those voices are saying, what those pictures are, and you train it just like the human brain. That's why we call deep learning algorithms neural networks, okay? And so for us in marketing, for us at Cognitive, what we do is we take who is already buying your product, and we use that to train a neural network, all right? And we can do that through a pixel. We can take CRM data out of Excel spreadsheets, et cetera. We can even use location data, and through Catalina, we can use shopper data, who is buying your products, all right, in actual retail stores. But we take all that data, let's say it's a pixel on your website of people who have on the thank you page, so that's people who are buying your products. We push it through our deep learning platform, and it starts to train a little brain, a little artificial brain with neurons, these digital neurons. And we use all these inputs like demographics, what the the user ID, the location of the user, the time, the site, and the other contextual features. We can use, which is the beauty of deep learning, thousands of these inputs. This, just for example's sake, are just a few of the types of inputs we can use to train a neural network. And then we say, okay, this user bought the product. And then we have other users that we say did not buy the product. And we start pushing that through the system and creating this neural network, just like our brains wire themselves to learn what an apple is and a green apple and what English language is. We do it over and over again, and we continue to test the neural network. At first, it's terrible at recognizing who is going to buy your product. Excuse me. But as we train it over and over again, and we test it and we tell it, hey, it's right, it's wrong, this was right, this was a good prediction, this was a bad prediction. We use all this testing data, the historic data of this person bought something, this person did not buy something. It guesses, and we keep telling it the answers, and we use this thing called back propagation to teach it that it was right or wrong, and it reprograms itself. You know, in this image, you're seeing sort of some of the connections get thicker or thinner, stronger importance between these things. And that over time, over a few hours of training, sometimes a day of training, we get to a point where we find that the neural network is accurate enough to go out there and recognize a new person that we think is likely to have an affinity for your brand and buy something. All right. And that's really how it works. So it's constantly learning and adapting, and that brain then gets set loose and starts to buy media for you, or identify audiences and build audiences for you. And it continues to do that over and over and over again and learn from its mistakes, even as it's live and buying media. Now, that's the learning. That's the self-learning. That's the automated part. That's the cool part about fully custom, fully adaptive automation, okay? So you don't have to have a person pulling levers anymore and trying to figure out what's working, what's not. The algorithm does it for you. But how do we get even greater scale that we're finding in any other opportunities out there, whether that's just context, just demographics, et cetera? Well, we do it through what's called infinite clustering. All right, that's what enables the scale in deep learning. Okay, so what does that mean? Well, this is a representation of a plot of all the users in the United States. Okay, so this is one of the things that comes out of the cognitive science team, is that we basically plot every user in the United States based on what we know about them, their demographics, their behavior online, all those types of things. And we plot them in relation to each other, how similar they are, right? There's no rhyme or reason to the axes on a plot like this. You just have to take for granted in this plot here that people that are close to these dots that are close together are related in some way. They are similar in some way. And the farther apart those dots are, the less similar they are. Now, this is a real plot that we took from one of our clients. Where we've labeled the purchaser, the customers of the client that we get from, let's say, a pixel, and those are the pink dots, okay? So we've got on this kind of three-dimensional plot some obvious clusters, okay? Those are the easy ones that you probably already know about from your own research, okay? Maybe that's the male 1849, makes $50,000 a year, and lives in a city, okay? Easy peasy, all right? Well, that's where you're hitting your limitation. You've already hit these clusters. You've already maxed those out. How do you get new scale? Well, if you look closely, there's tons of other pink dots, but they're dispersed throughout the rest of this user graph, okay? What about them? This is where deep learning is most powerful, because what it can do is it can take every single one of those dots and say, okay, this is a purchaser, this is a customer. What about all the dots that are close to this pink dot? So we don't have a cluster yet of customers, but we can build those clusters by focusing a certain distance around every single one of those dots and building out more and more scale from those converting those prospects to users. That's how deep learning gets its scale. And we call it infinite because if you look at this kind of a plot, this is the kind of brand that probably has appealed to a lot of different people, but it hasn't yet been able to figure out how to message or choose a new cluster without wasting a lot of money. Deep learning can do that in a sort of this experimental way of trying to hit little circles around every single one of these dots, find what's working, and then hone in on those new clusters until that maxes out, and then keep looking for additional new clusters as scale continues to grow. All right, so that's the cool part of deep learning. That's the little deep learning aside, and that's why you get this adaptive, self-learning, scalable solution. All right, so how does this actually work? Let's look at this in action. How do adaptive algorithms really help? Do they really help? Well, we're here to show you that we've found the proof. All right, so let's review. What does a deep learning adaptive neural network algorithm do? It's predicting consumer behavior in a general fashion. Okay, so it's generalizing your brand across the entire, in this case, United States, and looking for new pockets of users, and then also adapting to where those users are going to convert, what time, what place, what site, what context, etc. So it's basically one-to-one marketing, as we've always been promised, because every single different combination of time, date, place, context, and user is going to be different. One user is going to respond to a certain message in a certain context differently than another user in the same context. All right. It's all automated learning because, frankly, we as humans can't keep up or experiment infinitely the way a deep learning algorithm can do. And again, it's all self-learning. Okay, so Casper is one of our clients. I thank them profusely for being public about being one of our clients. They're one that's, you could even say, are they even a challenger brand anymore? But they're a brand that has been around a long time and has been marketing a long time and has been figuring out what works in marketing for a long time. And we loved having them come on board with a small test campaign. And that test campaign, as you see, has grown from a small monthly budget to 7 times that original budget. And so not only did they scale, but if you take a look at the return on ad spend, as they scaled, the beginning of the campaign was sort of that first little peak down there. And then once they began to scale their advertising and the algorithm really got hold and started to exploit all the new clusters, the return on ad spend went way up. And Casper, that they use ROAS as their main KPI. Okay, so not only did we decrease their cost per acquisition, but their ROAS went way up on average, and they were able, as they scaled their budget up. Okay, so this is solving that problem of customer acquisition costs go way up as budgets go way up. No, in fact, if you're using deep learning, you can keep customer acquisition costs either even or actually it goes down as you scale up because the algorithm gets smarter, has more data, and has experimented across more of those infinite little clusters. All right. Another D2C client that we have is Lola. It's a women's lifestyle brand. If you haven't heard of them, they began with just organic subscription for organic tampons and other feminine hygiene products, and have grown into much larger of a brand and are now in retail. And so actually they asked us to help them with brand awareness that drove sales lift in retail, in store. And as we've launched their first campaign digitally on display, they'd always been, using social, sort of the same problem of capped out ROAS. We've been on their first test campaign over the last few months, been able to reach 3 million new unique users that we believe were new to their brand, and they've seen 30% sales lift in store. And as you can tell, it continues to go up every week. This campaign is a good example of a campaign that's geographically targeted and targeted to retail and targeted to retail. All right, so almost finished here. I just wanted to also point out that this works for, excuse me, my phone is talking to me. Siri is not understanding what I'm asking. So we have the ability to prospect, but we also have with deep learning the ability to improve your retargeting. We also know that this is a problem that a lot of the D2C and challenger brands are facing, that they're spending a lot of money on retargeting. And yes, customer acquisition costs, return on ad spend are much higher than prospecting, but there's also a lot of waste still. So 60 to 80% of most retargeting budgets are wasted on users who never purchase your brand. You're also spending a lot more from a CPM perspective to drive those acquisitions in the end. Well, deep learning can help you weed out all the waste, identify the people who really are not going to buy your brand, and allow you to focus those dollars more efficiently and drive your ROAS on retargeting way up. Again, trying to drive profitability with growth. Okay. Casper actually uses this product also. Retention is also an interesting part that we're helping solve for companies that have been around a while. customer churn, getting people to come back is always a problem for all brands. But for those who see one purchase and then don't see follow-on purchases, deep learning is able to take CRM data and take a look at that and mirror that to the people who are actually making purchases now and try to figure out on generally a smaller budget how to bring people back to the brand, maybe to buy new products. Maybe it's time to hit them with emails and things like that to come back and re-up on what they bought. So not only can deep learning help you with prospecting, I think that's where you get the biggest bang for your buck on scale and helping that customer acquisition cost on net new users. But it can also help you save money or spend money more efficiently in the retargeting zone and possibly help you get some of your old customers back. All right, that's it. So in summary, right now, almost everybody is finding that there are limitations to search and social. ROAS and CAC hit a peak and get a lot worse once you get to a certain point of scale on Facebook, and especially with the iOS update. Deep learning is enabling a reverse of that on open web, whether that's display, video, etc., and helping continue to grow brands and drive their scale and lower their customer acquisition costs actually from where they are on social, and do that in an automated fashion, making it very, very easy for all these brands to continue their march towards dominance. All right, that's it for me. Thank you very much, and love to bring Stuart back to lead some questions.
All right. I should be back here now, Jeremy. Thank you. Great explanation, as always. Really interesting to understand what direct-to-consumer and challenger brands are doing these days. They are always, again, a step or two ahead, and it is an area where so many people want to learn from. We're going to move into some audience questions here in just a second. So I want to just take a moment here and invite you, if you do have a question for our speaker, Jeremy Fain, the CEO and co-founder of Cognitive, just simply use the question tool that you should be seeing there underneath the video window. Submit your questions. We're going to go about 10 minutes. We'll try to get to as many questions as we can. If we don't get to your question, submit it anyway. Again, we're going to forward all these over to our sponsor, so there is the opportunity for an offline response. Couple quick reminders. First off, if you want a copy of the deck that was shared today, we've got that available right now. You'll find it in Event Resources. You should see that tab also down there where you see the question tool. Also, webinar has been recorded and will be available on demand. We're sending you a link to that on-demand version about 3:30. So keep your eye out for that. Share that link with your colleagues. Better yet, if you've got colleagues who you want to get some of this information to, have them register. We'll send them that link directly. All right, let's move into some of these questions here, Jeremy. So let's talk a little bit about sort of the, you touched a little bit about different types of campaigns, and you were showing some of the things at the end here. But can you talk a little bit more about the types of campaigns, the types of messaging where deep learning really works best? Are we looking at things that are very performance heavy? Are we looking at things that are maybe a little bit more brand centric as this goes on? Does that even matter in terms of how you're going to use the technology?
Well, deep learning definitely works great on performance. Okay, so if you're trying to drive to a KPI like customer acquisition cost, cost per acquisition, return on ad spend, deep learning is really the only way in our experience to get the scale past all the other manual optimization type of things that you've been trying. So we really help most of our clients with performance advertising. That said, there is a new sort of offering that people are starting to take advantage of, especially in video, which we call behavioral branding, that allows companies to be a little bit more specific in where it's showing its more expensive advertising, such as video, instead of saying, okay, my core cluster demographics is this. Now I'm going to go buy television shows that have strong viewing in those demographics, or just buy demographic targeted ads in CTV or online video. We can actually go even further and look at the behaviors and those infinite clusters and target the brand messaging just around those purchasers, lookalikes, and the users that look a lot like them. So it's much more efficient use of branding dollars. That's a really nice new way that deep learning is helping folks.
Yeah. Good transition here to another question that's come in a few different forms, Jeremy, and that's sort of understanding the channels where tools like cognitive can be used most effectively. Obviously, we were talking a little bit about social and search and how brands need to start to move away from that, right? It's an area where we sort of have scaled out at times, and we talk about the open web. But the open web is, of course, quite big. So are you talking about things like connected TV? Are you looking at digital out of home? Are your clients sort of working across these channels, or is it more direct, traditional web-based advertising?
Yes, our clients are working across anything but, I would say, direct digital at home, just because there's not a lot of feedback of data there. We're even working with clients that were showing ads online on an app or computer screens, even CTV, and being able to track that to a purchase in store using data like Catalina. So there's the ability to do the things that some people are doing with Amazon, some of the retail media networks that aren't really offering a lot of data or analytics and not a lot of insight, and do that using the open web to drive to companies like Catalina that are already doing a lot of reporting for in-store retailers as it is. So it's very easy and simple and sort of old school for us now to do, hey, we're showing ads to people and they're coming and buying your product. Doing incremental lift studies and showing that we're delivering net new customers outside of what you've already been doing in other platforms, even Facebook. But really, the only thing we don't do right now is sort of out of home digital and linear TV, because we don't have the tracking mechanisms to say, okay, this person saw that ad and now we've seen them make a purchase.
Got it. As we talk a lot here about challenger brands, it is always the story of challenger brands, right? Their use of social, their use of Facebook, how that launched brands like, I don't know, Warby Parker or Hubble. Hubble, I think, was always the one that was that story of that got a lot of coverage of their use, right? Inexpensive, broad reach, good targeting. Obviously, that's not there for those who are just starting out, who have the ideas. So is deep learning an effective solution for, again, you shared two brands, obviously larger, more established in spite of their challenger status. Is this something that emerging brands that are looking to start out, that may not be scaling out there on social at the same way, should they be really looking at this kind of technology as they go forward for the smaller emerging startups?
Sure. We generally see success with companies who have more than 1,000 transactions a month. A lot of the time that doesn't seem to dissuade most emerging brands. I think that once you've gotten to a scale of about 1,000 transactions a month, deep learning is going to really help you superpower your marketing. And what we've also seen is, I think that's also a point, at least a minimum point, where Facebook efficiency starts to drop for some brands. Of course, for others, it can go way beyond that.
Got it. Look, standard question here, which is people trying to understand sort of the use of deep learning here, how it really gets learning. and sort of a sense here of, I guess I want to say, is sort of minimum size and variety of content that needs to be out there so that these algorithms can work. Can you give a sense of sort of timing and execution? And again, I know it's an always improving, right? Because it's always learning. But at what point does it really sort of get to where it really needs to be?
At Cognitive, we like to be able to prove that we can optimize a campaign within a month. That doesn't always happen, especially if you have a smaller brand, because there are fewer transactions than larger brands. So it's more about number of transactions, number of learnings. But we do our best to show that we can meet the customer acquisition cost targets within a month. We like to run for 3 months with any new client from a test perspective, because we believe that a month is just the beginning of what these algorithms can do. And most of our clients, where we are meeting those goals within that first month, have become long-term clients. We're talking about year to years long, well beyond just the first test, because as they continue to see, we have improvements on a regular basis until even, sometimes even we cap out. But we have customers that are spending millions of dollars a month on our platform and continue to have improving customer acquisition cost returns. So it really depends on the brand, how big the brand is, and how much sales we can drive. But we have clients that are $10,000 a month, and we have clients that are everything in between those millions.
Yeah. Jeremy, listen, we're fast approaching the end of our time here, unfortunately. Great presentation, and I want to thank you for taking some of the time here to answer some of these questions. We talk about direct-to-consumer brands. Every brand in this day and age is becoming a direct-to-consumer brand, as all of as our first-party data executions are changing on top of everything. Again, thanks for sharing all of this. Just some quick reminders to our audience. Again, if you want the slides, you're going to find them in event resources. Check your email later today. Link to the on-demand version for you to share. Adweek.com/webinars, our webinar calendar. Check that out. Sign up for an upcoming webinar. Check out the archive of on-demand webinars as well. And that includes some from our sponsors today, Cognitive. So again, Jeremy Fain and Cognitive, I want to thank you for your time today. I want to thank our audience for taking time out of your busy day. And we look forward to seeing everyone at an upcoming Adweek webinar. Thank you all.
Thank you, everybody.